Hi everyone. So let's now move on to the next question. Okay. Very important, repeatedly asked in the many of the question paper called working principle of a transformer. Very simple and easy to understand. People who are not knowing the physical concept of transformer, you still can easily understand this. So the principle behind the transformer is, please, mutual induction. So this is a principle behind the transformer. So let us understand what is this mutually induction. The principle of mutual exclusive induction states that when two coils are inductively coupled and if current in one coil change uniformly, then an electromotive force get induced in the other coil. So what exactly we are trying to understand here, we have two coils and these two coils are mutually coupled, they are mutually tightened. So we are supplying an AC current to coil, okay, which in turn converts an electromotive force in the other one. So this is what we call mutually induction. So one coil is inducting the other coil by producing an electromotive force. So let's understand this transformer by just drawing a rough figure. So let us take a bar. This is an magnetic field bar, okay, where both the end is wind off, right? So you can just winding off. And this side also you can coil it. This is what we call coil, okay. We are coiling it on both the side, right? Okay, and we'll have an AC current here or AC supply, and we are here on the other side we give the load, okay. So one side is AC supply, one side is load, and this is nothing but where the magnetic field, it is magnetic core, and this winding where the AC current is connected, right, is called primary winding. Where the AC current is connected, right, that is the primary winding, and this winding where the load is connected is called secondary winding, okay. So I repeat, one side we have AC current, along with AC, that is the winding of primary, and the another side load, along with the load what we have is nothing but the secondary winding. So here the current supply is on one side and load is on the other side. So current which passes through this side, okay, the current which passes through this side, which gives rise to magnetic flux in this magnetic core. The current which has been supplied as a AC unit, which gives rise to magnetic flux. I'll just mention here magnetic flux. As the time change, that is with respect to time, this magnetic flux will combine with this coil, that is primary winding, okay, and it will start giving rise to electromotive force, as we have already stated by Faraday's law of electromagnetic induction. So The AMF which produced is called a self induction EMF. So the magnetic flux which is produced, which also in turn acts on the secondary coil, right? Secondary coil. Because of this primary current at the primary winding and the magnetic flux, the secondary winding coil will also be induced by an electromotive force. So these two coils acts as a mutual inductance, where the current from the primary has been transformed to the current in the secondary. Hence the principle is named as mutual inductions. So mutual sharing of EMF happens in this transformer. So how are we going to represent this in terms of a symbolic form? That is the next step. So symbolically how we write? So here we have AC current. So we have drawn an AC current here. AC supply, okay, which is connected by the primary winds. Between the windings we have a magnetic field or magnetic core. Then you have a secondary winding and then the load. This is the symbolic representation of the transformer.